We're back, and we are going to be looking at section 5.6, which is, we're still with torsion, but we're going to be looking at indeterminate torque problems. We're going to approach these very similarly to how we did axial indeterminate problems. So let's just kind of go through what does indeterminate mean. So remember when we were way back in statics and we would draw our free body diagram and set up our equilibrium equations, that we had three equations of equilibrium. We could have three unknowns. And then we looked at internal pins, and if we had a pin that provided a kind of an extra free body diagram and set of equations. And so, but they were still all determinate problems. We could determine the solution using equilibrium alone. With indeterminate, we have to look at another option in order to get an extra set of equations. So if we look at this system right here, where we have this applied torque and we have a material 1 and a material 2, and they have different material properties. They might even have different geometries. Maybe one is hollow, one is solid. And if we set up our equilibrium, we're going to find that the reaction at 1 and the reaction of 2, okay, have to equal the 32 kip inches. And we can set up our equilibrium equations. And so if we are in pure torque, then we can sum our torque, and the sum of that torque should equal 0. So we can find that T1 plus T2 equals 32 kip inches, but we can't sum normal or moments or shear in order to get that extra set of equations. So what are we going to do? We can go back and we can now look at compatibility of deformation. And I know if I'm twisting where 1 and 2 are joined, then 1 and 2 both have to be twisting the same amount. They both have to be twisting the same amount. So they're going to have different stresses, but their twist has to be the same at the point where they're combined. So you can go to page 223 in your text and just look at how this is set up. And there are some really great examples that look at different situations where we have an indeterminate system. Number 1 is always equilibrium equations. You're going to draw a free body diagram. You are going to set up your equilibrium equations. And then you're going to determine, am I determinate or indeterminate? If we need more equations, we need to look at our geometry deformations. And so phi1 plus phi2 equals 0. And in that last case, you're like, but they're both twisting the same. But what we have to remember is they are both twisting the same. And as I come from the right over, positive twist, okay? From the left over, positive is twisting back towards me, but we are twisting away. So positive twist, negative twist when we look at those internals. So we're going to angle of twist 1 plus angle of twist 2 equals 0. We're going to find that, okay, that angle of twist 1 was negative, so negative plus positive equals 0. They should have that same twist. The deformation relationship is TL over JG, and then we apply that with our compatibility equations. And again, torque 1 in that case is going to either be negative or torque 2, depending on which way we're twisting, and you're going to solve the equation. So if I'm looking at, so it's twisting at me, as I come from the left, twisting at me in the middle is positive. As I come from the right, remember right hand rule, butt of our hand up to the cut, twisting away from me is positive. So I can see I'm going to have a positive angle of twist with one and a negative angle of twist with the other. And the sum of that should equal 0. So we can have like coaxial torsion members where we might have a core and a shell. And in that case, I know that the phi of 1 has to equal the phi of, the angle of twist of 1 has to equal angle of twist of 2. Because when we look at those members on the left, if I have a shell and a core, as I twist it, they are having that same twist. So angle of twist equals angle of twist. When I look at in series, that's where I'm going to have that the angle of twist of 1 plus the angle of twist of 2 equals 0, because one of them is going to be positive. One of them twisting in that same direction is going to be negative. So if you're still struggling with right hand rule, stop by my office hours or set up a Zoom appointment and we can go through determining positive and negative. And I think that's, oh, whoops, sorry. There we go. There was our relationship. So we are now going to stop, and I've got, I think, 3 or 4 examples we're going to work through.